Welcome to the Public Exam Review for Unit 1, Chapter 3 on Polynomial Functions. In this presentation, we will look at graphing polynomial functions by examining the graphs and coming up with the equation of the polynomial function. Here we will focus on using the zeros, roots, and x-intercepts of the graphs of polynomial functions to develop the equations. We will analyze the graphs of polynomial functions and use the graphs to develop the equations of the polynomial functions. In this graph, we will develop the equation of a cubic function. Notice that the graph represents that of a sideways f. Because it's a sideways f, we know that we're dealing with a cubic polynomial function which has at most three x-intercepts. The first x-intercept occurs at x equals a -4. The next x-intercept occurs at x equals 0. And the third x-intercept occurs at x equals 3. So here we have what are known as three single real roots. The equation of this polynomial function can be written as y equals a outside of x plus 4 multiplied by x minus 3 in factored form. We have y equals ax times x plus 4 times x minus 3. In order to determine the value of a, we need to find a point on the graph of the polynomial function that the graph passes through. Note that the graph passes through the point -5 and 4. We will substitute these values in for x and y into the polynomial function to determine the value of a. Notice also that the value of a will be less than 0 because the graph extends from down into quadrant 4 and up into quadrant 2. Here we have 4 is equal to a multiplied by a -5 multiplied by a -5 plus 4 multiplied by a -5 minus 3. We have 4 equals a multiplied by a -5 multiplied by a -1 multiplied by a -8. So here we have 4 is equal to a -40a. Dividing both sides by a -40, we have the value of a to equal a -1 over 10. As a result, the equation of this polynomial function in factored form is y equals a -1 over 10 multiplied by x plus 4 times x minus 3. In the next example, note the shape of the graph is in the shape of a W. This indicates to us that we are working with a quartic function. A quartic function will have a maximum of 4 x-intercepts. Notice that the graph is tangent at x equals a -2. That tells us that x plus 2 will have a multiplicity of 2 as one of our factors of the polynomial function. Similarly, the graph is also tangent at x equals 3. Therefore, x minus 3 will have a multiplicity of 2 as well. Knowing these factors, we can now write the equation in factored form as y equals a outside of x plus 2 all squared multiplied by x minus 3 all squared. In order to determine the value of a, we need a point that the graph will pass through. The point 0 and 72 will be substituted in for x and y into our function in order to determine the value of a. Notice that because the graph extends up into quadrant 1 and up into quadrant 2, we know that the value of A must be positive. So we have 72 is equal to A multiplied by 0 plus 2 squared multiplied by 0 minus 3. 72 is equal to A multiplied by 4 multiplied by, the x minus 3 there is supposed to be squared because of the double root at x equals 3. So we have 0 minus 3 all squared, which is 9. So here we have 72 is equal to 36A, and the value of A must equal 2. So the function then, in factored form, can be written as y equals 2 multiplied by x plus 2 all squared multiplied by x minus 3 all squared. And that's how you write the equation of the polynomial function when you're given the graph. Let's look at some potential questions that could be asked as multiple choice and constructive response questions on your public exam. Which statement is true for the polynomial function graphed? As I look at the function, I know because the function is the graph is a sideways S that we're dealing with a cubic function. All cubic functions are of degree 3. So that eliminates A and B as possible multiple choice items. Looking at the graph, there is a double root at x equals a negative 5. And we know that there's a double root at x equals a negative 5 because the graph is tangent at that point. The graph is tangent at x equals a negative 5. Therefore, you would see x plus 5 with a multiplicity of 2 as one of the factors of this polynomial function. As well, we have a single root at x equals 4. It's considered a single root. Therefore, the correct response for this multiple choice item is a function of degree 3 with a double root at x equals a negative 5 and a single root at x equals 4. That corresponds with D as your multiple choice item. In example 2, which represents the graph of f of x? As I look at the shape of this function, I see a squiggle, what I refer to as a squiggle. That tells me that we're working with a quintic function, which is of degree 5. I see single roots at x equals a negative 6, a single root at x equals a negative 6. Therefore, the factor will be x plus 6, and it will just have a multiplicity of 1. I also see a single root at x equals a negative 4. Therefore, we will have x plus 4 as one of the factors of multiplicity 1. Another single root occurs at x equals a negative 1, so the factor will be x plus 1 equal to 0. In the last case, I see that the graph is tangent at x equals 5. Therefore, there is a double root at x equals 5, and the factor will be x minus 5 raised to the power of 2 because we have a multiplicity of 2 to equal 0. The only multiple choice answer that corresponds with this is D. You have x plus 6 times x plus 4 times x plus 1 times x minus 5 raised to the power of 2. In example 3, which of the following equations is possible for the following graph of f of x? Notice that the graph in this case is in the shape of an M. It's M-shaped, therefore we are dealing with a quartic polynomial. the leading coefficient has to be less than 0 if the graph extends down into quadrant 4 and down into quadrant 3. So that eliminates A as a possible multiple choice item. I see that we have single roots at x equals a -3. Therefore, x plus 3 will have a multiplicity of 1. We have another single root at x equals 5. Therefore, x minus 5 will be another factor of the polynomial function. And as well, we have a double root. Notice that the graph is tangent at x equals 0. So we have a double root at x equals 0. So you will see x squared to equal 0 as a factor in the polynomial function. All values of A equal a -1/15, so we don't need to determine the value of A. We just need to look for the characteristics of the factors of the polynomial function. That corresponds with D as the correct answer. There you have x squared, which was where your double root occurred. X minus 5 indicates a single root at x equals 5, and a single root when x plus 3 equals 0, which occurs at x equals a -3. This is a constructive response item whereby we have to algebraically determine the equation of the polynomial function graph, determine all intercepts, and leave your equation in completely factored form. Again, the shape of the graph is W-shaped, which indicates to us that we're dealing with a quartic function. The leading coefficient A has to be greater than 0 if the graph extends up into quadrant 1 and up into quadrant 2. I notice that there are single roots at x equals a -8. Therefore, x plus 8 will have a multiplicity of 1. We also have another single root at x equals 4. Therefore, x minus 4 will have a multiplicity of 1. And I see that there is a double root at x equals a -3 because the graph is tangent at x equals a -3. Therefore, x plus 3 will be raised to the power of 2 because it has a multiplicity of 2 to equal 0. So far we have y equals a outside of x plus 8 multiplied by x minus 4 multiplied by x plus 3 all squared. In order to determine the value of a, we need to pick a point that the graph of the polynomial function passes through. We are given that the function passes through 2 and a -25. So we will substitute these values in for x and y to determine the value of a. Here we have a -25 equals a multiplied by 2 plus 8 multiplied by 2 minus 4 multiplied by 2 plus 3 all squared. Simplifying, we have a -25 equals a multiplied by 10 multiplied by a -2, and 2 plus 3 all squared is equal to 25. So we have a -25 is equal to a -20 multiplied by 25 equals a -500a. Dividing both sides by a -500, we get the value of a to equal (1/20). So the equation of this polynomial function is y equals 1/20 multiplied by x plus 8 multiplied by x minus 4 multiplied by x plus 3 all squared. And that's the equation that we were asked to algebraically determine. We were also asked in this case to determine the y-intercept as well. The y-intercept is this point right here. In order to get the y-intercept, you can let x equal 0 in order to get the exact coordinate. So then y will equal 1 over 20 multiplied by 0 plus 8 is just 8. 0 minus 4 is a negative 4. And 0 plus 3 all squared is equal to 9. So here we have y to equal a negative 32 multiplied by 9 divided by 20. The y-intercept will occur at negative 14.4. And the question asked us to describe all intercepts, so it's important for us to include the y-intercept as well. In the last example, we have, again, to find the equation of the polynomial function in factored form, given the graph. Provide all necessary details. So again, I see an M-shaped graph. The M-shaped graph tells me that we are working with a quartic polynomial function. We have single roots at x equals a negative 3. Therefore, we have x plus 3 to equal 0 as one of the factors. Another single root occurs at x equals a positive 3. Therefore, x minus 3 will equal 0, has a multiplicity of 1. And then we have a double root at x equals a negative 1 because the graph is tangent at that point. Therefore, x plus 1 will be raised to the power of 2 because it has a multiplicity of 2. So far, we have y equals a multiplied by x plus 3 multiplied by x minus 3 multiplied by x plus 1 all squared. In order to determine the value of a, we will substitute the given point 1 and 13 in for x and y to get the value of a. So y is 13. It will be 13 equals a multiplied by 1 plus 3 times 1 minus 3 times 1 plus 1 all squared. 13 is equal to a multiplied by 4 multiplied by a negative 2. 1 plus 1 is 2, squared will be 4. So we have 13 is equal to 4 times 2 is 8. 8 times 4 is a negative 32a. When you divide both sides by a negative 32, your value of a in simplest, as a reduced radical or as a fraction in lowest terms is a negative 13 over 32. So the equation of this polynomial function is y equals a negative 13 over 32 multiplied by x plus 3 multiplied by x minus 3 multiplied by x plus 1 all squared. As well, we are asked for the above graph to solve the inequality where f of x is less than 0, stating the answer in interval notation. The region where f of x is less than 0 is the region below the x-axis. The region below the x-axis occurs when x is less than, and I will highlight the region, when x is less than a negative 3, and again when x is greater than a positive 3. So to write that as an interval, we would say that it's when x belongs to a negative infinity comma, -3 with a round bracket, union with 3 comma infinity, again with a round bracket. Because at a -3 and at x equals a +3, the function is equal to 0 at those points. So the function will be less than 0 in the interval when x belongs to a -infinity, comma, -3, union with 3 comma infinity. The summary of key ideas for this section is that the x-intercepts on the graph will give the factors of the polynomial function. If there is a single real root, then the factor will have a multiplicity of 1. If there is a double root, then the factor will have a multiplicity of 2, and the graph will be tangent at that x-intercept. If there is a triple real root, then the factor will have a multiplicity of 3, and the graph will flatten at that x-intercept. The graph will pass through a point x and y. We can use the coordinates of that point to determine the leading coefficient of the polynomial function. We leave our answer in factored form, y equals a times x minus b times x minus c times x minus d, and so on. If you have any questions related to the content of this presentation, please pose your question in the question forum, and I will be happy to answer it for you. Thank you.